So I'd like to go back and summarize G protein coupled receptor pathways in a minute, but before doing that, I need to talk about one very important mode of regulation that I've alluded to earlier, but I want to make a little bit more specific. So I talked about protein kinase A feedback inhibition functions, and that's associated with phosphorylating this region of the activated G protein coupled receptor, which signals a desensitization phenomenon that is basically feedback inhibition. But there are other ways of doing essentially the same thing that lead to inhibition and other possibilities as well. Among those is the activity of this protein, G protein coupled receptor kinase, which does more or less exactly what I described with protein kinase A. Phosphorylates this loop, and that leads to downstream inhibition and other phenomena. And also protein kinase C can do that. So you end up with potentially an arrangement of phosphorylated residues here, and that serves as the recruitment signal for another protein that binds to that region called arrestin. It's also called beta-arrestin. I'll get to that in a minute. But before we do anything further, you can see that this protein is just sitting across the region of the G protein coupled receptor that the heterotromeric G proteins want to get to in order to be activated. So that physical block of downstream interactions is an inhibition associated with desensitization. So that very effectively blocks the way that the G protein coupled receptor would ordinarily activate effectors, whatever they are, whether they're activators themselves or inhibitors. That's going to be blocked. But beta-arrestin has its own features as well, and they're important for things other than simple physical steric blocking of G protein coupled receptor pathways. And that's shown in a diagram from the other text. So the beta part stems from the fact that probably the most studied G protein coupled receptor of all is the so-called beta adrenergic receptor. It's famous for a lot of reasons nowadays, probably mostly because of the so-called beta blockers that represent a gazillion-dollar industry in drug markets. But beta-arrestin in this diagram is interacting with those phosphorylated residues, again deposited by any of G protein coupled receptor kinase, protein kinase A, protein kinase C. But because it attracts other proteins, other fates are possible. So here is a arrangement of our old friends from endocytosis. AP2 is the adapter protein that is associated with clathrin vesicular trafficking pathways. So because those two things bind, you end up with clathrin-coated pits, endocytic vesicles, and the standard endocytosis. So this could just be another desensitization pathway. G protein coupled receptors are being removed from the plasma membrane, and therefore the ligand can't find a receptor to activate. So that essentially desensitizes the cell and turns off the response. But because endosomes are potentially long-lived things, and the signaling domain is still facing the cytoplasm, even in endosomes, this could be a way of prolonging the signal from G protein coupled receptors, or potentially sending the signal somewhere else in the cell for localization processes. But the other thing to keep in mind is beta-arrestin binds other things too, one of which is the protein C-Sarc that we'll get to when we talk about MAP kinase pathways, because it's a key component of the activation of those pathways. So now, by virtue of activating a G protein coupled receptor with some ligand, let's say epinephrine for example, bringing in beta-arrestin, you can activate a completely different type of pathway that we normally associate with growth factors, not with hormones. But that's what I mean when I talk about the crosstalk between these signaling pathways. There will be several other examples of that. Here's one that we probably won't talk about because we don't talk about the c-Jun pathway, but that's another means by which G protein coupled receptors can participate in pathways that we normally associate with other receptors. Okay, so if we go back to the Wikipedia diagram that we basically started with, it's now time to sort of finish up that discussion, because we've covered everything by now. So here's ligand binding on the extracellular phase. And then we have gray and blue domains. That's associated with the alpha subunit of the heterotrimeric G proteins binding. This little green area is where the beta gamma of the heterotrimeric G proteins bind. So in terms of the successful signaling, that interactions would be the GEF activity that leads to downstream effector activation. This region right here is where we have the beta-arrestin phenomenon. So here's the sites that are phosphorylated by G protein coupled receptor kinase. This protein kinase C phosphorylates one of the same residues in protein kinase A. Likewise, so you get those phosphorylated residues and you get desensitization, as is indicated right here. Here is a region that localizes the cytoplasmic tail to lipid rafts, or at least that's the theory. And the rest, yeah, we've covered. So now we can go back to these originally ridiculously complex diagrams and see that we've covered them all. So we didn't really do 12, 13, but here's alpha S, alpha I, working on the cyclic AMP, protein kinase A pathways. Here is alpha Q doing some things that we'll talk about later, other signal transduction pathways. But you can see down in this region, crosstalk, here's a fairly standard looking MAP kinase pathway associated with G protein coupled receptors. Here's beta gamma operating on phospholipase C, and that leads to the calcium spikes that we talked about, activated protein kinase C. There's a crosstalk that we'll eventually get to whereby phospholipase C beta activates RAS, and that's definitely the canonical MAP kinase pathway. Beta gamma can also directly activate some components of growth factor receptor tyrosine kinase pathways. So much more crosstalk available here. And then here's an examples of just some beta gamma signaling, and we've talked about some of these. The principal association that you need to make is with the phospholipase C, but there are other possibilities as well.